Several months ago, we kind of started on this little D902 Kubota engine. Valve seat had fallen out of it, busted the head up real bad. We kind of experimented, attempted to repair that, and I think we could have, but our customer did find where he could get a brand new head for it that was real nice shape and reasonably priced, so he opted to do that. But then they wanted us to go ahead with the block here, and we thought we were just going to hone this so he could re-ring it. And lo and behold, when we run hone down through there, we found this dent in the side of the cylinder from when it had that catastrophic failure. And we magnafluxed at that time and could not pick up as though there was any crack there. But my gut level told me there probably was, because I've seen failures like this in the past that left a dent in the cylinder, and usually there was a crack associated with that.
And basically, it had dropped a valve seat, bent the rod, and probably kind of all happened at the same time with denting that. It cocked the piston, probably.
Cocked the piston, got some of that in there. So anyway, we have found ourselves a cylinder repair sleeve that I think I can make work on this. I'm confident enough that I'm going to make the repair. I'm going to charge the customer for the repair, but if it does not work, I will give them their money back on this. I'm not going to leave them hanging with that, but I'm confident we can make this work. Now, as I set up here, I thought, you know what, let's magnaflux that one more time. And I don't know if you can see that or not, but there's a little tiny line up and down there that at this point I've managed to detect with the magnaflux, so I believe it is cracked. So anyway, this is kind of an unusual cylinder. It has some big notches at the bottom there for the rod to clear, but that's kind of below the water jacket area of the block. So I'm going to bore down to that point, press this sleeve in, that'll repair our crack, deck the top off again, make it flush, and then we do have 0.25 millimeter pistons. We're going to bore all three cylinders for the first oversized, one and only oversized there, and see if we can make this engine go down the road again. Actually around the lawn with this
down the road.
Yeah, down the road to the lawnmower, to the grass where they're going to mow with their lawnmower. Over here I've done my math. I have standard size piston is roughly 2.835, and if I take a 70 thousandths first cut here, a 70 thousandths second cut, and then that'll get me to 2.975. My sleeve OD is 2.9862. If I allow 2 thousandths press fit on that, I need to make the final bore for that sleeve 2.9842. Once I get to this point, that'll leave me, about 9 thousandths for a nice finish cut, so I can get a good round hole to press that sleeve into. Once that's all done, the idea that will need to be bored to 2.8445. Well, actually a few thousandths shy of that. We'll probably go about 3, maybe 4 thousandths shy of that, and then finish hone the block to that size for the new pistons. I have set my cutter in a micrometer to that size of 2.905. Off camera there, I had come down on my cylinder here with the centering fingers, and I have centered in that cylinder. I put a feeler gauge under the edge of my cutter, and again, I had measured down, I need 4 1/16 inch long sleeve in there to stop right at the bottom of where that notch is cut. So 4.062, ready to start the machine and then engage, and I just have to watch when I come to 0 and stop. So let's see what happens. Hope that's right. I'm still on 0 up there, X and Y, so. $200 thousandths, 100 thousandths. I'm going to hand feed the last. There we are. So anyway, looking down inside here now, take a look there on the sides of where I bored to for the bottom of that, to catch the top side of the notch, the bottom where I want to go with the sleeve. And I think I came out just exactly where I want to be there. But if you look over on the side here where we thought that crack was, if I get in the light just right, I can see a funny band.
Can you try to magnifluck it now, or
We could.
just for fun?
Just for fun.
Nothing?
No, I'm not. I don't see it with the powder on there now, but there's a difference. Something in the metal there is just a little bit different. So I think it was a good call on our part to attempt to put a sleeve in that rather than just send it down the road the way it was.
Okay. Well, put your other cutter in. 70 thousandths more.
Yeah. I should have set up the little dust collector here. Do you see all that iron dust floating around in the air? Gives us black lungs.
Oh well.
400, 300, 200, 100. Half. 0.
There's something weird there for sure.
Not yet. We should have, what I decided there, another 10 thousandths to go.
10 thousandths including press or not including press?
10 thousandths not including press. 9 thousandths will get us where we need to be for the press. Okay, this should be our final cut. I've sent the cutter to 2.984.
Sleeve measures
Sleeve is about
986.
986, a strong 986. There, are we ready to go again?
Yeah.
I'm not sure I understand.
Series ready.
Series ready to go, yeah. Okay, let's go for it. No, don't do that. Yeah, that sounds like a lot lighter cut there. Yeah, that's only taking about 5 thousandths off each side.
It looks about right.
Yep. Look at that pile of chips we got out of it.
Pretty big pile for a little tiny sleeve.
Yeah.
So if that is a crack,
Well, the sleeve is going to cover the crack, basically a band-aid over the crack. It'll give it a little more structural support in the cylinder where that's cracked. Obviously, the water coolant is going to come up behind the sleeve, but with a press fit, it probably won't go any farther than just up to the sleeve. But when we put this in, we'll put some Loctite around the bottom, and a little bit of Loctite around the top, and that way, if the coolant did decide to migrate around the sleeve, the Loctite on either end will seal that up, so you'll never get any coolant into the oil or any coolant up into the cylinder. And like I said, the sleeve itself is a band-aid over the crack, so that will keep any coolant from coming into the cylinder itself. We've put in an awful lot of sleeves over the years and a lot of awfully nasty looking broken up blocks, and for the most part have had good luck with them. 400, 300, 200, 100. I'm going to go just a little bit more so I get a nice square cut at the bottom. There we have it.
you stopped the cutter where the line almost went right up with the weird spot in the cylinder.
Huh.
My eyes might be lying to me, but I could swear you can see a fine line there with that.
Well, we probably ought to check it again. There it's showing.
There you go.
Can you get that?
Yeah.
This is where that's discolored. I'm guessing that that has what little time this engine ran as it was failing. It either pushed some compression through there and kind of impregnated the metal, and now that's kind of showing, and or the antifreeze came back into that a little bit and discolored the metal to where it's showing.
So I guess the moral of the story is trust your instincts,
Yeah.
or remember your experience.
Remember your experiences, remember your bad experiences, and trust your instincts. Okay, I've set this gauge to exactly the size of the sleeve. A 0 on here is the size of the sleeve. So let's see how much press fit we're going to have. Slightly over 2.
Probably a good spot.
Yeah. Much more than that, you can stand a chance of cracking across to some of these steam holes and whatnot. So I think we're in a real good spot with that. Down at the bottom of this cylinder, there's not a lot of step there. And when you get these new sleeves, they think they're being special and doing something nice for you, and they put this big, huge chamfer on here to make that go in easier. And I understand why they do that. But in our case here, where we're going to end up taking most of this out, not much step there, it doesn't leave us much to sit against here. So a lot of times a sleeve like this where I have extra material, I'm going to put my own chamfer on this top edge, but just a real small one, just enough to be able to get that started in there. And I'm actually going to install that sleeve upside down from what the manufacturer intended for it to be done, because we're going to cut the top off here anyway. So let me go put just a chamfer on that by hand, and a belt sander over here. I bet you people at home wish you had a donut now. Doesn't take very much, just enough to knock the sharp edge off there.
You know, even though I bought those for work, I paid cash with my own money instead of using the company card.
Well, that's a first. What, you forget to leave the card at home today?
Yeah, I couldn't find my wallet.
This thing is too small a cylinder for me to get my fat finger down in there. So I'm going to use a Q-tip here and put just a teeny tiny little coating of Loctite around the bottom of that sleeve, or bottom of that bore for the sleeve. I'm going to put a small amount of this press fit lube on the cylinder wall above that area. Give it a little lubrication so hopefully it doesn't try to gall on the way down in. And just for grins, I don't think it would necessarily need it, but I'm going to put a little Loctite right around the top of this. A lot of what we do here is just for feel good.
Yeah. Depending where the head gasket seals, it may not even...
Yeah, this, if the head gasket's real close to the top, or to the top edge there, it'll probably actually be over the edge of this new sleeve. Okay, so there we have a little Loctite on it, just for added insurance. Hear that? We hit bottom. That's not going anywhere. So I've reset my cutter with a different blade in here that will face the top of that sleeve off, parallel to the top of the block. I've adjusted it slightly larger than the outside of the sleeve will be.
Not going to use the cardboard?
Yeah, but I just wanted to show to begin with. Can you see that?
Sounds kind of nasty.
Yeah, that. I don't think that cutter is as sharp as it could be. And it looks like somebody else is taking the edge off another time. Let's see what else we got in here. There's one with a good edge on it.
Okay, so different cutter, hopefully
cutter.
sharp.
Hopefully a little sharper. Yeah, that sounds more like it. How about I quit there though? We can take that off with when we surface the top of it there.
Whatever you want
Clean
to do.
that up. Well, I'd rather not go too far here. So now we're boring the inside of that sleeve, rough finish sleeve, to our oversize for the pistons. I could probably do that in 2 cuts, but let's do it in 3. Be a little easier on everything here to get it right. This cut is going to be roughly 40 thousandths.
Do you have a stop set?
No. We could have real easy here. So those cylinders are measuring 4.5 inch. So I'll set our stop over here at 4.5. A lot of people are concerned about our tape measure being calibrated. So I'm just going to go off of our dial indicator here. I'm going to set 4.5.
Dial indicator.
Our digital.
You really are.
Yeah, I'm losing it this afternoon. Our digital calipers here, roughly 4.5 inch. Check it here. Yeah, it comes out 4.5. So there, our tape measure has been calibrated.
That's good.
I like the way these sleeves machine. Whatever the material is, they make them out of. It cuts real nice. They seem to wear real well, but on the flip side, they do cut real nice. Leaves a nice smooth finish.
Yeah. So cut number 2, you said?
Yes.
Will this bring it to standard size?
This will bring it about to standard size.
Okay.
Okay, I'm set to final rough bore size, which is about 3 thousandths smaller than what we want to hone the cylinder to when it's finished. Very, very light cut.
So you can still kind of see the edge over there, but by the time you hone another few thousandths out of it,
Yeah, it'll be
hidden.
hidden. Yeah, the seal must be bad on the bottom of this head. It's dripping a little bit of oil out.
Okay,
All right, so now we got 2 more cylinders to bore.
get it done.
Barely touching. Hopefully it cleans.
Cleaned up all the way?
I believe so, didn't it?
Must have.
It's clean. It's good.
Cleaning guy says it's clean. It
Yeah.
must be. We need to get those shirts made.
clean all the way around?
Cleaned up all the way around.
Good.
Let's get out of here.
Okay. We'll come back Monday, change heads. We've already decked this block because we didn't know it had a bad cylinder in it until after we started honing them. But anyway, we'll come back and deck this, but I'll just come down and just barely skin just enough to make the top of that sleeve fit, and we'll be good.
And then we'll hone it, and it'll be done.
That can leave on Monday. Huh? This job can leave on Monday. It's been holding down the bench over there for, what, 6 months?
Yeah.
So everybody else has gone home. I've had my supper. Some quiet time here in the shop. I thought I'd try to see if I could get this little block honed. So, let's see if I can turn this camera around. Okay, there we got the camera turned around. So I've got this little Kubota block in the hone here now, and just kind of going through the setup on this. I have, as per the checklist here, it says shim the main guide. So I have taken the main guide out and put it in the fixture here and made sure that it was shimmed properly. And I've shimmed the centering guide. I did not using alignment guides. I put some brand new stones in here. I've got those shimmed properly. Let's see, let me put this down in just a second. I have set my stroke length here, I don't know if you can see that, to 4.5 inch, which is what the cylinder measures. And I have set the speed and the stroke length, stroke speed, by adjusting these belts. And I think we're ready to start honing on this. So let me set this camera up in a tripod and let's see what happens.
All right, so you honed the block when I was gone, right?
Yeah.
Give us a rundown on how it came out and where we're at.
Finished up the hone on this, and I do have some video I shot on my phone of setting up the hone a little bit and doing that. But anyway, once we got done rough boring this, we had about 3 thousandths to finish hone out of it. And we set it up and went through our process there to hone it and get the correct surface finish on there. And it actually turned out really nice. I was quite pleased with the way this came out. And looking at it here, if you didn't know, I don't think you'd ever be able to tell there was a sleeve in there. But if you look real close here, you can see just the edge, maybe a little different color in the middle there where the top edge of the sleeve is. And down in the bottom, I don't know if that's anything you can see on camera there, or put a little more light on it here. I put the sleeve in. We stopped right at the top of where that notch is, make it a little easier to put in, and it all blended in the bottom real well. So anyway, I think it'll work good. I mean, after all, this is what we started with for a piston. These chunks here are part of the old valve seat that dropped out of the head and busted up the top of the piston, the head. And after we had that kind of dent in the side that we found when we was honing it, and after we started boring that, making our cuts, it became more obvious that was a real small little crack started in there. So I'm glad we did opt to put the sleeve in. And granted, that sleeve is not probably a Kubota approved method of repairing this. They want you to just replace the block. But we've discussed it with the customer, and they were willing to give this a shot. We'll guarantee our work on this. If it doesn't work, I'll give them their money back, and they can go buy a brand new block. Otherwise, hopefully it runs a long, long time before this new piston looks like that piston.
As long as they keep it cool.
As long as they keep it cool, I think it'll be fine.
And I was going to say, when you were talking about it, you know, that it became more obvious it was a crack, I feel like it became less obvious and then it became more obvious, because for a while there was just that
there
discoloration.
Was a kind of discoloration that we could see in the cylinder wall, but as we got closer to the finished size for the sleeve, it became obvious with the Magnaflex that there was a crack there.
Yeah.
Yeah.
A lot of work for a stupid little block.
Yeah, awful lot of work for a little motor. Definitely labor of love as opposed to anything to make any money on, because it took just as much time to do this as it does a big motor.
Yeah.
If
That
not
thing's
more.
not engineered to be rebuilt.
No, they were definitely throwaway motors, but I was surprised customer managed to find 0.25 millimeter oversized genuine Kubota parts. I thought we was going to have to go with some Chinese import stuff here at first, but he did find the original stuff. So hopefully they can put it back together and not have nearly as much money in it as what a replacement engine would have been, if you can even get one.
Yep. All right.